Alright, welcome back. In this edition of Fun in Math, we are going to look at addition and subtraction using mixed numbers. Now, when we're talking about mixed numbers, addition and subtraction is going to be the same, where you still have to have your common denominator. Now, with that, the only thing that's going to make adding and subtracting with mixed numbers different from adding and subtracting with just simple fractions is the fact that before you even get started, you have to change your mixed number into an improper fraction. Once you do that, you then are able to find the least common multiple of your denominators and then combine your fractions together. So I have 5½ plus 3 7/10. So I have to change each into improper fractions or into fraction form. So what I know is that my denominator is going to stay the same, and then I'm going to do bottom times the big number plus the numerator, and it goes into the top. So this is bottom times the big number plus the numerator. Well, I need to do the other fraction. Again, its denominator is going to stay the same. And again, this is going to be bottom times the big number plus the top into the top. So I have 2 times 5 is 10 plus 1 is 11. So this is going to be 11 over 2 plus, and then I have 10 times 3 plus 7 gives me 37 over 10. So in order to combine them, I have to find the least common multiples between 2 and 10. Well, I could divide them out by primes, but one way I can actually do it is if I know for a fact that one denominator will go into the other, then I'm basically done. And I know 2 will go into 10 nicely, and it goes in there 5 times. So I can skip the divide prime out part and just simply go to creating my fractions to be the same. So in order to change 2 into 10, I have to multiply by 5. So 11 times 5 over 10 plus 37 over 10. 11 times 5 is 55. So this is going to end up being a single denominator, and I have 55 plus 37. Well, 55 plus 37 is going to give me 92 over 10. Now, since I started with a mixed number, it means I should probably end with a mixed number. So to do that, says I'm going to do long division. So I'm going to go ahead and set that up. The numerator goes inside, the denominator goes outside. 10 does not go into 9, but 10 goes into 92 9 times. 10 times 9 is 90. Leaves me with 2. So this is going to end up being 9 2/10. Well, if you look at just this fraction here, notice it can reduce. So we need to. 2 and 10, 2 can go into 10 5 times. So this is really going to be 9 1/5, and this is the overall result. Okay. Let's go ahead and look at another one. So I have 23 5/16, and this time I'm subtracting. And it's 16 3/4. So again, I have to start by turning them into mixed or improper fractions. So I'm going to have 16 on the bottom And then this is going to be the denominator times the big number plus the numerator. And I am subtracting that, and this is going to be 4 on the bottom. Again, denominator times the big number plus the numerator. So then I have 16 times 23 plus 5 is going to give me 373 over 16. And then I have 16 times 4 plus 3 is going to give me 67 over 4. Now, in order to find commonality between 16 and 4, I can very easily see that 4 will go into 16 nicely. So I'm going to start with 373 over 16. I'm subtracting. My new denominator becomes 16, and this becomes 67 times 4. Well, 67 times 4 is going to give me that 373 over 16 minus 268 over 16. So in this case, it means the whole thing can be over 16. So I have 373 minus 268, and that is going to leave me with 105 over 16. Well, I still have to change this back to its mixed number. So just like before, the numerator goes inside, the denominator goes outside. Okay. 16 does not go into 10, but 16 goes into 105 6 times. 16 times 6 gives me my 96. When I subtract that away, I'm left with 9. 16 does not go into 9. So this is going to give me 6 and 9 over 16. And that is my result. Okay, let's look at another one. So here I have 42 minus 3 7/8. So if I remember, this is going to end up being 42 over 1, because any whole number is actually over 1. And then I'm going to subtract away. My denominator is an 8. 8 times 3 plus 7. So bottom times the big number plus the numerator. In doing so, we end up with 42 over 1 minus 8 times 3 is 24 plus 7 gives me a 31 over 8. What's in common between 1 and 8 is 8. So I know this becomes 42 times 8 over 8 minus 31 over 8. 42 times 8 is going to give me 336 minus 31, and the whole thing is over 8. So here this is going to become 305 over 8. Now, just like before, we need to change that over to its mixed number form. So again, 305 goes inside, 8 goes outside. And we look at how many times does 8 go into 30? Well, 8 goes into 30 3 times. 8 times 3 is 24. Leaves me with 6 behind. Drop down that 5. And we look at how many times does 8 go into 65? Well, it's 8 times. Subtract away 64 leaves me with 1. 8 does not go into 1, so this means I have 38 and 1/8 as my answer. Now let's look at going ahead and doing this when we have 3 terms. Again, we're going to start the same. We have to turn each of these into their improper counterparts. So first we're going to start by having 3 on the bottom, and this becomes 3 times 45 plus my 2. I'm adding that to the next one, which is 5 on the bottom. 5 times 31 plus 3. Add it to the last one, has 4 on the bottom. 4 times 12 plus 1. So we start back off with our first one, and on the top we end up getting 137 over 3. We're going to add that to the next one, which is 158 over 5. Add it to the last one, which ends up being 49 over 4. And now we need to find least common multiples. Okay? So here we could look at 3, and we can look at 5, and we can look at 4. 3 would break down into 1 and 3, which leaves me with 3 to the first. 5 breaks down with 1 and 5, leaves me with 5 to the first. 4 gives me 2 and 2, which is 2 squared. Since we want the greatest of them all, we're going to take all of them. Okay? If you look at my primes, notice 2 squared is 4. So in this instance, dividing out my primes leaves me with the same idea. So my least common multiple can be found by doing 3 to the first times 5 to the first times 2 squared, or it can be found by doing 3 times 5 times 4. So sometimes when in doubt, multiplying all of your denominators together will give you what's called a common denominator. In rare cases, that common denominator is actually the lowest common denominator, but that is another surefire method you could use to find something in common. Well, in this case, all of those give you 60 as a result. So when we look at 3, we need to look at how do I go from 3 into 60. Well, I do that by multiplying by 20. So this becomes 137 times 20 all over 60. I'm adding. 5 into 60 means multiply by 12. So this is 158 times 12 over 60. And then 4 into 60 I multiply by 15. So this is 49 times 15 over 60. So I can put this whole thing over 60. 37 times 20 is going to give me 2740 plus 158 and 12 gives me 1896 plus 49 and 15 gives me 735. This gives me 5371 all over 60. So now I need to interchange that back. So again, long division says the numerator goes inside, the denominator goes outside. So when we're looking at this, we need to look at how many times does 60 go into 537? Well, it's going to go in there 8 times. Okay. So then we have 60 times our 8 is going to give us, to subtract out, 480. When we do that, we are left with 57. 57 is less than 60, so we know we're on the right track, and carry down the 1. I now have 571. So I want to look at 9, which is going to be 540. When I subtract that away, that's going to leave me with 31. I have nothing else to carry down, and 60 does not go into 31. Therefore, my result is going to be 89 and 31 over 60. Now the other thing to notice is that 31 and 60 don't reduce. Therefore, I have finished my problem. Now the last thing that we can do, just like with everything, is instead of giving you the problem, we can give you the application. So in this one, again, we have that Casey's beagle is 14¼ inches from shoulder to floor. Her basset hound is 13 5/16 inches from shoulder to floor. So the question says, how much shorter is her basset hound? So in this problem, what we're setting up is that we have 14¼ minus 13 5/16. So we need to change each of them into improper fractions. So for my first one, I'm going to have 4 on the bottom. So this is going to be 4 times 14 plus 1. And I'm subtracting away with 16 on the bottom. And this is 16 times 13 plus 5. So I have 4 times 14 plus 1 is going to give me 57 over 4. And I'm subtracting away 213 over 16. Now don't panic because it appears as though this one is negative, because notice my denominators are not the same. I need to make them that. 4 can go into 16 nicely by multiplying by 4. So what I end up with is I have 16 on the bottom, and this becomes 57 times 4. And I'm going to subtract away that 213 over 16. Overall, I've got 16 on the bottom. 57 times 4 is going to give me 228 minus 213. When we subtract that away, this ends up being 15 over 16 inches shorter. Now, since this is a proper fraction, there is nothing else for me to do because it is already in not only fraction notation, but it is also in mixed notation. Now we have, using 45 inches of fabric, Sarah needs 2 3/4 yards for a dress and 3½ yards for a coordinating jacket. How many yards of 45-inch fabric are needed in all? Okay. So the only thing that we care about is the amount. So we have 2 3/4 plus 3 1/2. The fact that we're talking about 45-inch fabric, well, here's a fabric lesson for you. This right here is the width of the fabric bolt, i.e. it doesn't matter in our problem. What matters is how much length we need, which is where these yardages come from. So I have to turn each of these again into improper fractions so that I can combine them. So my first one is going to have a 4 on the bottom. This becomes 4 times 2 plus 3. And I'm adding that to a 2 on the bottom with 2 times 3 plus 1. On the top, I'm going to end up with 11 over 4, and I'm adding this to 7 over 2. Well, 2 and 4 have something in common, which is 2. Therefore, here I've got 11 over 4 plus 7 times 2 over 4. So this is going to give us over 4. So this is going to be 11 plus 14, which is going to give us 25 over 4. Since this is improper, we need to change it over. 25 goes inside and 4 goes outside. 4 goes into 25 6 times. Subtract out my 24 leaves me with 1. Therefore, I have 6 and 1/4 yards needed. Now, notice with both of these two problems, we have these descriptions added to them, or the labels. The labels are incredibly important when dealing with problems like these, because we're actually answering a question. Last, we have this problem that says a rectangle is 7 5/8 inches by 9 3/4 inches. What is the perimeter of the rectangle? So let's go ahead and take a look at your rectangle here. So I have 7 5/8, so 7 5/8, and I have 9 3/4, so 9 3/4. I need to remember that perimeter is the same as twice the width plus twice the length. Therefore, what I actually have here is I have to take a walk around my shape. So I am stating that my width is going to be 7 5/8 and my length is going to be 9 3/4. Well, with each of these, I have to convert them over into their improper fractions. So for my width, I'm going to have 8 on the bottom. This is going to be 8 times 7 plus 5. And my length is still going to have a 4 on the bottom. So 4 times 9 plus 3. So here, 8 times 7 plus 5 is going to give me 61 over 8. And 4 times 9 plus 3 is going to give me 39 over 4. So when we're talking about perimeter, we are talking about twice the width plus twice the length. So here, the other way that we can look at that is width plus length plus length. So we can actually set this up in two different ways, and I'm going to go ahead and run through both ways fairly quickly, just so you can see both approaches. If we use the multiplication approach first, this says we're setting up that we have 2 times our width, so 61 over 8, plus 2 times our length, 39 over 4. When we multiply, we need to remember that the 2 is a whole number on the outside, and multiply says you go straight across the top and straight across the bottom. So this would really be the same as saying 2 times 61 all over 8 plus 2 times 39 all over 4. What's in common between 8 and 4? would be 8. So here, there's a couple ways at this point that we could go. First, we could just go ahead and keep with our multiplications and go from there. Or, second, we could recognize that in both of these fractions, I have a reduction that can occur, and it happens right here. And in this reduction, notice 2 goes into 8 nicely. This becomes a 1, and this becomes a 4. And 2 goes into 4 nicely. This becomes a 1, and this becomes a 2. Thus, changing my fractions down to being 61 over 4 plus 39 over 2. Now, between 4 and 2, 2 goes into 4 nicely. So this is still going to be 61 over 4 plus 39 times 2 over 4. So when we do that, now we have the whole thing is over 4. And we're going to have 61 plus 78. And this is going to give us 139 over 4. Now we're going to come back and deal with that in a second, but I wanted to show you what it looks like if you had set up to just simply add. We had already identified my width, and so here this one would have been 61 over 8 plus 61 over 8 plus 39 over 4 plus 39 over 4. In here, what we notice is that we have 8, 8, 4, and 4. What's in common there is that 4 goes into 8 and it takes it twice. So this would end up still being 61 over 8 plus 61 over 8 plus 39 times 2 over 8 plus 39 times 2 over 8. Which means my whole thing is over 8, and this is going to be 61 plus 61 plus 39 times 2 is going to give me 78 plus 78. And then we would simply have to add them. So 61 plus 61 plus 78 plus 78 is going to give me 278 over 8. Now, you might be thinking, hold up, wait a second, aren't these two completely different numbers? Well, they're actually not, because if I were to divide top and bottom over here by 2, what you would notice is that this one reduces down to being 139 over 4. And looky there, they're the same number. So, whether you use the formula, twice the width and twice the length, or you just simply add them all up as you go, you're going to get the same result. Now, at the end of the day, we still then need to change this back over so we can tell what the perimeter actually was. So, in order to do that, again says that we are going to put the numerator of 139 in, the denominator out. We know 4 goes into 13 3 times. Subtract away the 12, leaves us with 1. Carry down the 9. 4 goes into 19 4 times. Subtract the 16 away, leaves us with 3. So my end result is that we have 34 3/4 inches. So that is everything that you need to know in a nutshell to get you started with adding and subtracting your mixed numbers. If you have any questions, please be sure to let me know. Otherwise, just keep smiling. Remember to ask tons of questions. Have fun with your math, and I'll see you next time.